Hello friends, today we are going to start with Surveying and Leveling 2 Theodolite Traversing. In this we are going to see the Gale's Traverse Table, the terms which are used when we are defining the Gale's Traverse Table, the various aspects of Gale's Traverse Table, and then we are going to look at the balancing the traverse, the closing error, and how we clear off the error and how we balance the traverse. In order to understand that, first term which we need to understand is the term bearing. Bearing is defined as the direction of a given line with respect to a given meridian. Now, in compass surveying, we understood meridian as the north-south direction. Bearing is any angle which we take with reference to that fixed line. That fixed line could be the north-south direction, or it could be any fixed line which we can fix with the help of a theodolite. In a theodolite, we can have a fixed line, and with reference to this fixed line, we can get different angles to different lines. So each of these could also be defined as bearings. Now, when we talk of bearing, there is a very important term which we need to understand, and that is the whole circle bearing. When we look at this sketch, there is a traverse over here which is FGHIJ closing back on F. It's an anti-clockwise traverse. Now look at the line HI over here that shows the north-south direction and the east-west direction. Now the angle with respect to the north of the HI line, the angle theta from the north of the HI line is called as the whole circle bearing. The whole circle bearing is measured clockwise with respect to the north, and this is the whole circle bearing. The angle theta is the forebearing of the line. Okay, an angle theta dash over here, an angle theta dash over here is the back bearing of this line HI. HI, this is the forebearing, that's the back bearing over here. Please note theta and theta dash, the difference is always equal to 180 degrees. For example, if the bearing of the line HI, the whole circle bearing of the line HI, if it is 200 degrees, theta dash, that is the back bearing of the line HI, is 20 degrees, the difference between them would be 180 degrees. Now this is one of the most important relationship which we find between the forebearing and back bearing. Most of the times it is true that we will be finding that the difference between them is 180 degrees unless otherwise there is some error. So the forebearing of the line HI is 200 degrees, the back bearing of the line HI, that is theta dash, is 20 degrees. Now the acute angle, the line makes with the north-south direction or the fixed direction or the meridian is called as the reduced bearing or the quadrantal bearing. So whenever we are defining that bearing, that acute angle bearing, then we will be defining it as the north or south direction, then the theta, and the east or west direction. Like as in this case, it would be south, theta, west. The bearing of the line HI would be south, theta, west. The bearing of the line IH or the back bearing of the line HI would be north, theta, east. Let us look at this. The whole bearing of HI was 200 degrees. So whole bearing IH was observed to be 20 degrees. So forebearing of HI in reduced bearing terms or quadrantal bearing terms is south. Now how much would be this? This whole thing is 200 degrees and from north to south is 180 degrees. So 200 minus 180, balance is 20 degrees. So it is south, 20 degrees west. And this bearing over here of the line IH or the back bearing of HI would be north, 20 degrees east. Please note over here the forebearing And back bearing will have the opposite poles over here and opposite directions over here with the same value, unless there is some error as I mentioned earlier. So these are the quadrantal bearings or the reduced bearings, and these are the whole circle bearings. Coming to two important terms, very important terms of the traverse when we are solving for the traverse, when we are trying to plot the traverse, is the latitude and the departure. The latitude of a line is its projection on the north-south line. Now first thing is, look at this line. In the same traverse FGHIJ, look at the line FG. If I look at it from this direction, the projection of this line on the north-south line is here, from here to here. Now that is given by, it is equal to the product of the length of the line and the cosine of the bearing. Now the theta over here is the bearing of the line FG. So this value over here is given by the latitude of the line FG is given by the length of the line into cos of theta. The latitude is always measured parallel to the reference meridian, parallel to the fixed line. Now let us take the example. Say this theta over here is 60 degrees. Say this length over here is 10 meters. In that case, the latitude of FG or the projection of FG on this line over here would be given by LFG cos theta. Now LFG is already given to be 10 meters and theta is given to be 60 degrees. So LFG, the latitude of FG is 10 into cos of 60 degrees is 0.5. So latitude of FG is 5 meters. That means the projection of this line on this vertical axis over here is equal to 5 meters, or the latitude of the line FG is 5 meters. Let us take another example. To find the latitude of the line IJ. In order to find the latitude of the line IJ, we use the same principle again. The angle it makes with the vertical over here, this angle theta is given to be 80 degrees. This length over here, length of IJ is 15 meters. So latitude of IJ or the projection of IJ on the vertical axis, if you can see over here, the projection on the vertical axis is given by length of IJ, latitude of IJ is equal to length of IJ into cos theta. Latitude of IJ is equal to 15 meters into cos of 80 degrees. So latitude of IJ will be equal to 15 meters into cos of 80 degrees is 0.174. So latitude of IJ is equal to 2.60 meters. So the projection of this line on the vertical axis is 2.60 meters, or the latitude of line IJ is 2.60 meters. Now coming to the term departure. Departure of a line is its projection on the east-west line or perpendicular to this. So when I'm looking at the line FJ, please note over here, looking at the line FJ, when I'm looking at it from top, the projection, the component which I'm finding over here on this axis is called as the departure. It is given by product of the length of the line and the sine of its bearing. Whatever is the theta, so length of the line into sine of theta gives me the departure. Remember, the departure is always measured perpendicular to the reference meridian. Reference meridian is this, so it is always measured perpendicular to the reference meridian. Let us take an example. Theta is 60 degrees. The length of FG is to be taken as 10 meters. The departure of FG, or the projection of FG on this line is equal to LFG into sine theta. As per the formula, it is LFG, that is length of FG, into sine theta. Departure of FG will be equal to, the length of FG is 10 meters, sine of 60 degrees. So departure of FG is equal to 10 meters into sine of 60 degrees is 0.866, or departure of FG is equal to 8.66 meters. That means the projection of this line on the horizontal axis or the east-west axis is 8.66 meters. That means the departure of line FG is 8.66 meters. Let us take another example. Line IJ. Where would be the departure of this line IJ? Obviously, it would be on the horizontal axis on top. So when we see it from here, we see the projection over here. Now the departure of the line IJ is given by IJ sine theta. Let us take an example. Theta is 80 degrees. The angle it makes with the vertical is 80 degrees. Length IJ is 15 meters. So departure of IJ is equal to length IJ into sine theta. So departure of IJ is equal to length of IJ is given to be 15 meters into sine of theta is given to be 80 degrees. So departure Ij is equal to 15 into sine of 80 degrees is 0.98. So departure Ij is 14.77 meters. That means the projection of this line Ij on the horizontal axis is 14.77 meters, or departure of Ij is 14.77 meters. So today what we have done is we have tried to understand the terms bearings, the whole circle bearing, reduced bearing, quadrantal bearing, latitude, departure. We have also performed some calculations in order to understand the bearings, the reduced bearing, the whole circle bearing, the values how we get of latitude as well as departure. Thank you.